Hi everyone. In this video, we are going to study about the stack and the operations performed on the stack. So let's see the definition. A stack is a linear data structure that follows the principle of last in, first out. So what is the meaning of last in, first out? In stands for the insertion and out stands for deletion. And the last in, first out means whichever element will come last, that will be deleted first. Sometimes we say first in, last out also. Means whichever element is coming first, that will be deleted last. So let's see one example here. Let's suppose we are inserting the elements in the order 1, 2, 3, and let's suppose 4. Now, first in, last out means whichever element is coming first, that will be deleted last. And last in, first out means last element 4, which will be deleted first. It means the insertion and deletion, both we are doing from this end. If you want to insert the value, you can insert here 5. If you want to delete the value, you can delete the value 5. We cannot delete 1 now. So we can say that elements in the stack can be inserted and deleted from one end only. And that end, usually we call it top. Because usually we draw the stack in the form of vertical array, and the vertical array you write like this, and whenever we get the last element, that element will be called a top element. That's why we name it as a top. A stack is an abstract data type with a predefined capacity, which means that it can store the element of a limited size. If we implement the stack using array, then you know that array is a static data structure, and the static data structure, we need to define the size in advance. So we can say the size is limited in the static data structure. We will see now what are the operations that can be performed on the stack. The first two operations are push and pop. Push means we are going to insert an element. The push operations we will perform when we are going to insert an element. Let's suppose we are going to insert 7, and I will say push 7. When you delete an element, then in the stack, the term we will use is pop. So if you delete the element, then automatically it will delete the top elements. So no need to mention that which elements we are going to delete. It will automatically delete the top element of the stack. Is empty and is full functions. These two functions are used to check whether the stack is empty or not, or the stack is full or not. Peak function. The peak function will give you the top value of the stack. Let's suppose if we have some values in the stack 4, 2, 3, okay, and this index of this is 0, 1, 2. You know that the last value is on the top. The top is now 2, but the value at the top index is 3. If you call the function peak function, it will give you the answer 3. Next is the count. Count, rarely we use it because already we are going to display the elements. There we can see how many elements are present. But the count function also we can implement. It returns the total number of elements available in the stack. Display. The display function is very important function because whenever we perform some operations, we always will check that how many elements are there, and the element we are present, then we are displaying all the elements. Or sometimes we use the term traverse also, right? Traversing all the elements means printing all the elements of the stack. Now, let's see the examples. Initially, when the stack is empty, then we will initialize the top value to the -1 because the value at the top will be -1. When we increase the value, the top value will become 0. So whenever we want to insert the value, First, I will increase the value of top, and that usually we call it top plus plus, or top is equal to top plus 1. Now, here we can insert the value, means there will be an array, or let's suppose here we are using stack. So, a of 0 is equal to that value. Or in general, we can say we are inserting the value at top position, and whatever value is coming, that will come. When we want to insert the element, then I'm going to perform these two steps. So one by one, let's suppose if I want to insert another element or push another element, then again I'm increasing the value of top. The top will point here now. Now, in this value, I can insert 2. Again, I'm pushing the value. You can see here, you can mention like this also, that we are pushing 3. Pushing 3, then what I'm doing? I'm increasing the value of top first. Then at this position, 0, 1, 2. At this position, we are inserting the value 3. Here, we are performing the pop operation. Means we are going to delete the 3. Obviously, the value will be deleted is 3 here. So what I will do? I will return the value first. First thing I will do is I will return the value. Means I'm going to print that value that I'm going to delete this value. Then I will decrease the value of top. When you perform pop operation, these two operations or these two instructions we are going to write. First is for printing the value of the deleted element. Second is top minus minus, that we will bring top back to the next level or next index. In the example number 2 also, you can understand that initially top is -1. When we push 50, the top value is increasing 0. When we increase the value again, 40 I am pushing, then the value of top is again increasing. We push again, then the value of top is again increasing. If we, let's suppose now we perform pop, then the value, you know, that 90 will be deleted and 50 and 40 will be there. And top will point to the index number 1. So in this way, the working of stack is performed. As I already performed the working of the stack, so let's see what we are doing. A pointer which we are using, that is called top pointer, and that is used to keep track of the top element in the stack. Initially, when we initialize the stack, we will set the top value to the -1. So whenever we want to check whether the stack is empty or not, then we can check by this condition. If top is equal to -1, then we will print the stack is empty. On pushing the element, what you will do? As I already explained you, first I will increase the value of top, and then we will place the new element in the position pointed to the top. When we delete, means when you pop, on popping an element, we return the element pointed to by top, and then we will reduce the value of top, means then I will perform top minus minus. Before pushing, usually we check whether the stack is full or not, because if the stack is full, we cannot insert the value. So first I will check whether the stack is full or not. If the stack is full, I will just print that stack is full or stack overflow. Before popping also, we will check, because if you want to delete the element, first you should check whether the elements are present or not. The element is not present, means I will check this condition, top is equal to -1. Now I will print stack is empty. Otherwise, I can delete the element. Now we will see the steps of these algorithms, push and pop. When we push the element, what I will do? Step number 1 is just trivial step start. The main thing is step number 2. In step number 2, I am taking the input. Means store the element, that number which we want to push into the array. So that number I will take from the user. Step number 3. I will check if the top is equal to max size minus 1. And what is the max size minus 1? The max size is basically the size of the stack that we will define in advance. The max size is, let's suppose 5. So total value can come in the stack is 5 only. 0, 1, 2, 3 and 4. So value of top can be maximum 4. That's why we are checking if top is equal to max size minus 1, that is 5 minus 1. Then we will print stack is full. Sometime we write here stack overflows. This term is called stack overflow. Then we will go to step number 6, means exit. But if the stack is not full, let's suppose top is somewhere else here. Let's suppose. So we have 2, 3, 4 here. Now I want to insert the value. So I will increase the value of top. So top is equal to top plus 1 I will do. Then finally I will add the element a of top is equal to none. And step number 6 is exit. Next is algorithm for pop. Step number 1 is start. Step number 2, we will check first if the top is equal to minus 1, then I will say stack is empty and we cannot delete the element. I may write here stack underflow also. And we'll go to step number 5. Else, we'll go to step number 3. Then I will print the element that we which want to delete. I will print the deleted element. And step number 4 is decreasing the value of top. Top minus minus. So step number 5 is exit. Now let's see one example where we can understand these operations. The question is, what is the value of peak function and the top when we perform following operations on the empty stack of size 7? So when we have been given empty stack, and we can consider top is equal to minus 1. So I will draw that stack. Size of the stack is 7. So 0, 1, 2, 3, 4, 5, and 6. So 0 to 6 means the size of the stack is 7. First operation is given as push 3. When we push 3, the value of top I will increase. When you increase the value of top, the top will point here. So now I can insert a of 0 is equal to 3. The 3 will come here. Again, the second operation is given is push 8. 8 we want to push. Again, the value of top will be increased. And finally, I will put the value 8 here. I can remove top from. Next is the pop. The pop function means we are going to delete 8. Top element will be deleted. To delete this element, the top will point to the 0 index now. Next element inserted is minus 1. First, I will increase the value of top. The top value will become 1. Then, the a of 1 will become minus 1. Next is the pop operation. For pop operation, again the last element that is minus 1 will be deleted. And the value of top will be pointed to the index 0. Again, the pop operation is there. Again, the value of 3 will be deleted. The value of top will become minus 1. You can see here the index is minus 1 means the stack is empty. Next is push 6. To perform push 6, value of top will be increased. To perform again push 9 means top will come here. Again you perform push means top will come here. Now there is a pop operation. So if you have pop operations, again 4 will be deleted. The value of top will be now here. And finally, last operation is also pop. So again the 9 will be deleted. the value of top will decrease and the value of top will come on the zero index. Now you can say the function peak will give you answer 6. It will give you the top value and the value of top, that is the index, is 0. By this example, we can understand how stake is going to work.